How's it going, everyone? Euler Gonzalez here. So, right now, what we're gonna do is record a series of videos based on the NeetCode, which is now taught by Navdeep, which he is he previously worked at software engineer at Google, as well as Capital One, and now he is the content creator of his own channel and founder of NeetCode. So the idea here is that based on his experience, and to me it was quite interesting, he have now this particular course called the NeetCode as a way to now help you how you are going to be able to understand patterns as a way to solve problems. How you're going to use is this computer science concepts and tools as a way to solve real life problems. So that's the entire goal of this. So understand the patterns for understand computer science. Exactly. Understand computer science concepts and tools to solve. Exactly. So understand computer science concept and tools to develop a pattern, or in this case to build. Exactly. So understand the computer science concept and tools to develop a pattern, to develop a pattern recognition is a pattern recognition, because it's this: understand the computer science concept and tools to develop a pattern recognitions for solving real life problems, for solving real life problems. Okay? Using these arrays and hash, 2 pointers, stack sliding, stack, linked list, and binary search, which is the mid-level. Okay? Which is the mid-level. But the idea here is to understand the computer science and tools to develop a pattern recognition for solving real-life problems using this data structure. Exactly, using data structure and algorithm. Using common data structures and algorithm. Such as array and hashing, 2 pointers, and all of this. But the idea here is that given this particular concept and this tool, how you can solve real life problems using this data structure and algorithm as a way to solve common real life problems. Exactly, for solving real life problems using common DSS and algorithm. All right. So that's the entire goal of this series of videos, and we're gonna start it with the methodology, which is 45-minute daily. Okay, and we're gonna start here with array and hashing. You know, array and hashing. Something that I'm quite familiar. I am definitely quite familiar with this. It's like I'm not a stranger to this. So let's get into this. Let's get into this. Array and hashing. So let's go into now dive deep into this particular roadmap that we get in here. Okay. We also have backtracking, graph, WinDP, bit manipulation, math and geometry, and all of this kind of thing. But first, let's going to start is with this, you know, with the roadmap. As a way to say, hey, let's going to actually solve this particular problem here. We can assign it here, okay? You can sign up with your GitHub account. You're going to actually sign up with this GitHub account. Okay. And let's going to start with JavaScript. Another thing here, okay, is that all of these problems comes is, but I prefer to actually do this. So all of these problems actually comes is with this from the NeetCode, which is this contains duplicate. So hey, contains duplicate, and that's what we're gonna do here, you know, and that's exactly what we're gonna do here. Contains duplicate. So this is now the NeetCode, and let's going to start with that. So giving an array, this is the roadmap here, followed by the roadmap here, the roadmap. Is this one, okay? So followed by this, we're now going to do is this. So giving an integer array of nums, return true, and we're going to dedicate just only 20 minutes to understand this kind of problem. Only 20 minutes to dedicate to run this problem. So giving an integer, I don't think I actually registered here. It's supposed to be here. I think I already have this. Okay. And you got this. No, I don't believe you. Let's gonna do this. Design in here. That's right. There you got it. Okay, exactly. We already solved this contains duplicate, right? So giving an array, an integer array, nums, return true if any value at least, okay. Giving an array of integer nums, return true if any value appear at least twice in the array, and return false if every element is distinct. So this is how we create this, right? This is the way of how we create is this. Again, this is one solution, but the other solution is to say, hey, instead of doing that, okay, here we're going to do is this. I want you to now is, here we're going to create is a set, create a set, okay, to create a set which holds unique values, okay, to compare that, exactly. So create a set, it's going to actually do this. So here we're going to say is create a set which hold unique values, okay, to compare the set, create a set, this data structure, which is behave like a hash but now it has key value pair, but now this allows us to have only unique values, which is great. Create a set which holds unique values to compare the set, to compare each unique, exactly, to compare each unique number in the array, in the nums array, okay, to compare each number in the array with our set. If that number exists in our set, if that number exists in our set, that's one of the things that we need to first declare. That what is the input of this, you know? So input is an array of nums, okay, and the output is a boolean. It's a boolean. All right, so here we're gonna say is, hey, create a set which holds unique values to compare each number in the array with the set. If that number exists in our set, return is contains duplicate. Yeah, return true. Otherwise, return false. And that's exactly what we're gonna do this. So by creating this duplicate set, all you can say is, which will be the result. Yeah, the result will be is false. Here, you can just do something like this. Okay, create result false, and here's what we're going to create is our set, which contains the value duplicated, or which contain is all of this data. Let's gonna call is our unique value, or to be more explicit, I prefer to use this, is duplicated, is value, or is duplicated, exactly, is duplicated, initially is false, you're going to start with that, create a set which holds unique values, which is, let's going to create here a set, or you can say is duplicates, as a way to say here, is this new set, okay? Okay, duplicate, like this, or duplicates here. And then let's go to compare each number in the nums array with our set, which means is that because we can use the iterator protocol, which is something much more convenient here, by saying is for cons, I want to get is the value of an iterator, which is in our case nums, is an iterator. It will give us the value from that. Okay, so if the value, okay, if that value does not exist, for example, duplicates has value, so if this value is in, so duplicate has value, so if you haven't that value, so let me add that. Let me say duplicates add duplicates add that value. Okay, otherwise, if you have that, all right, it means that I need to break this. Okay? It means that I find this element here that exists, okay? Exactly, it means that I find this duplicate data that exists here, which means that this actually contains duplicate, and therefore I'm going to break this, okay? But before break it, I'm going to say, hey, is duplicated equals to true, which means that if that number exists, set that in our array, in our set. You know, if the number exists in our set, exactly, add it. If not, then let's go into the flag that we have here is duplicate is set to true, which now contains duplicate, and I don't want to keep that. Which means that I'm going to now is optimize the performance of this. So by say, let's going to return is duplicate. So when you run this, now using is that particular syntax, especially when you run this, okay? Because it must be is exactly a variable, a let, not a const. And there you got it, right? Actually worked as expected. So I don't want you to continue evaluate this as it is. For that. It beats 80.8.60% like that. So it's actually 74% for that. But again, it's because it's now we are using is some of the built-in for that. You know, we are now looking is that some of the built-in for that. Some of the built-in for that. Intuition, approach, complexity. Describe your first thought on how to solve this problem. Okay. An editorial. No. And then solutions. Optimal approach with explanation. Come on. Exactly. Optimal approach with explanation. But as you can see here, we can actually add some notes here. As a way to see is this. So intuition. So iterate through nums array. Yeah, iterate through num array, and when we find any duplicate, stop the execution and returns true. Yeah, iterate through nums array, and when we find any duplicate, stop the execution and return true. This is the intuition. Interesting. Intuition, approach, complexity, space complexity, and the code. Iterate through the nums array, and when you find the duplicate, stop the execution and return true. Otherwise, false. The reason here, exactly. So the approach is using the ES6 features using the new ES features, okay, we can now in a declarative using now the ES features like set iterators, let's say iterators, we can now be more descriptive about how we want to be more descriptive about what to do. You know, using the ES6 features, using the ES6 feature, we can now be more descriptive about what to do instead of worrying about how to do it. Useful to handle large collections of values. You know, useful to handle large collection of value. The big data era. In the big data era. So we got the complexity, we got the space. So here the complexity it'll be is on is linear time if this has to iterate exactly on if the duplicate element is on the last index, okay, which is the worst case scenario. So worst case is that, and best case is worst case scenario. Okay, and it comes to explain with space complexity, we had is on if the duplicated element is on the last index. Okay, so time and the space here is linear. Is decent, you know, is a decent for that. There's nothing wrong with that. But yeah, using ES6 features, using ES6 features like set and iterator. Exactly. So num is an iterator which allows us to get, num is an iterator which allows us to get the current value. And after we evaluate the block's scope, it gives us by triggering a next method from the array, from the iterator object, and after we evaluate the block scope, it gives us, by iterating, by auto triggering a next method from the iterator object, and give us the next value. This is quite interesting. This is a very quite interesting approach in how you're going to describe this and how important is this. It is to do this, you know? Yeah, it is. And how important it is to do this. So, well, actually that was it. The solution here, we put this solution. Here. And that was blazing fast. You know, it's like we already know what we have to do, so it's not that difficult. And if we go now to interesting. This is way much more even powerful. If you already have, if you already have this new set with the sides, and if they're, create a new set with the sides here, that's awesome. Create a new set here, and I want you to evaluate this. Okay, this is an alternative that I think that is much more powerful. Again, this actually works as expected. There is no problem with that. But this particular solution here, this particular solution here is actually something interesting. It's actually something interesting. Very, 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 very interesting. Because of course, all of this I need to iterate through that, and so on and so forth, right? All of this need to iterate through that. When you use a for loop, you get to do that. Return true, otherwise that. So means that break that. This is another one. So you can see here, you can now make it much more simpler, your solution. But again, the trouble is that, good, but for those people that actually don't know how the language works, it is important to improve readability. You know, it is important to improve readability. It is important to improve the readability. I really love this because now what you're passing is this iterator here, You say, hey, I want you to now give me is, oh, this is another beautiful thing here. The solution was beautiful because you say, hey, because we're passing is this array of elements, and if there are numbers, I want you to get this. I want you to compare the size. I want you to compare is the size here. I want you to compare is the size here. So for example, if you run this, it actually runs that blazing fast. Sometimes it's fast, sometimes it's not, but in any case, you get the idea. That's lovely. That's lovely. Okay, what's next? What's next? Is this one, right? Valid anagram. Okay. Given to string S and T, return true if T is an anagram of S, and false otherwise. An anagram is a word or phrase formed by rearranging the letter of a different word or phrase, typically using all the original letters exactly once. So one way to solve this is by saying, hey, we got the input. The input is toString, which is input toString, okay, S and T, all right, and the output is, well, do you have now is a Boolean, okay? So the idea here is to say, hey, if this word is an anagram, it's a word or phrase formed by rearranging the letter of a different word or phrase, but they must have the same length for that. So one way to do that is by you tell the computer, hey, I want you to sort this. I want you to sort at least one of them, okay? And once you do that, compare that. You know, once you do that, compare that. So because we already have the string 1 and the T and the string 2, okay? One way to do that is by saying is the object.is, which compares the value, is the value are the same, by saying, let's gonna do this. Let's gonna get this the string and the string 1. And we say, hey, I want you to now is sort the first element, okay? Sort the first element, which is a string. Question is, do we have sort in a string? Do we have sorts in a string? Okay. No, we don't have sorts because that is something. We don't have sort in a string. We don't have sort in a string. That's right. Match all, match, blah, 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 blah. We don't have sort in a string. We don't have sort in a string, so we can convert that into an array. Okay. How so? Glad you asked. We can do something like this. We can say is sort string, okay, or sorted string, sorted first string, okay, or sorted string, sorted first string, to be more declarative and say, hey, because one of the beautiful things of using the ES6 is you say, hey, I can now spread all of these elements using the spread syntax, and tell that if the next token is a string, which is an iterator, I want you to now expand all of these items into an array. So now I get these elements into an array. So what I can do here, assuming that this is an string, okay, I can say is, before actually doing that, I want you to transform all of them to lowercase, okay? Okay, so transform this string into lowercase so we can then compare that, because the idea here is this. Sort the first, so the approach is this. Source the first string, okay, by, exactly. So sort the first string by make it all of it is charge. Okay, all we can say is this: make all the charge. Oh, I can do this. What is this? Source the first string, because the pattern here is that I'm starting is with that. Sort the first string by make all of it is charge. By making all of it is charge lowercase, okay, and then compare the value with, and then compare it, and then compare it, and then compare the sorted first string, okay, and then compare the sorted first string with, yeah, and then compare the sorted first string with t, the second string. Okay, so this is how we can indicate, hey, I want you to make all of these elements lowercase to lowercase, put all of each character in there as a lowercase, and then use the spread operator as a way to put all of these elements into an array, because at the end of the day, and a string is a special type of iterators. It has now this iterable protocol, which is the iterable function that indicates how is, which is something you can customize, what will be is the iterative logic here when you use the for of syntax, okay, and the iterator protocol, which is what is you're going to return when you call that function, or when you call each one of those elements. So you're going to follow is the iterator protocol. So once you do this, I want you to now sort that, and by default it's sorted by ascending order the array. Array sort. It sort that by array it's sorted by exactly. It's sorted when this is a character, it's sorted if it is omitted, the array elements are converted to a string, then sorted according to each character's Unicode point value. It is assorted to the Unicode point value. It should return a number where is this. To memorize this, remember that AB is equal to the A minus B. Source number in ascending order. If omitted, the array elements are converted to a string, then sorted according to each character on the Unicode point value. But it's going to now do that in the Unicode points value. So we are relying now is on the Unicode point value. It have now 1 million code points. No, but this is not a quick tour. It's the list of Unicode character. Exactly. So now it's gonna take a look at this table and compare those characters, man. Take a look at that table and compare those characters, man. Exactly. It compared that, but it compared that by the Unicode point, and I don't know why it's taking too long to actually load the Unicode point, but it compares by that. Hey, this is the table that I have here, and if this value, based on this table here, okay, decimal, okay, decimal. Based on this value that I have here, especially the Unicode, because it's pointed to the Unicode, as I mentioned here, it's the Unicode point value. Is the Unicode point value. So whether it's uppercase letter, okay, as well as lowercase letter. So I want you to compare that. Hey, if this code is the same as the next code, all right, they are the same. But if not, then they are not the same. You know, and they're going to order based on the Unicode. Based on the Unicode code point value. In other words, here is going to do that in an ascending, in an alphabetic order. In an alphabetic order. So we can say is to sort, or because what we're doing here is to actually return is a new that. Okay. And then we're gonna say is this. Now that we have is this, but as an array, I want you to then join that to transform them into a string. Okay. And then we say, hey, compare the sorted string with the second string. With object.is allows us to do that, to compare that. For example, this is different from double equation, because it doesn't, because double equal set is a type coercion. Object.is is different from the triple equal because unlike the triple equal, it doesn't evaluate is not a number, for example, or not a number with it doesn't consider is not a number values or positive or negative infinite value, where now this actually allow this. So object.is, if the sorted first string is the same as the t, which is the second one, all right, I want you to return this. And that's it. Anagram, it's a false. Okay. To sort and then join with this. Exactly, then join that. Interesting. Here I'm saying is like, hey, I want you to now create an array with all of these elements at lowercase. Well, so put all of these elements at lowercase and then transform them into array. All right. I get it. Now I know what's happening. I know what's going on. It's because we need to pass the values as an iterator, because it's value because it's added to lowercase. Exactly. To lowercase. Okay. So I want you to transform is this. First, I want you to transform is this to lowercase. Okay. Exactly. And then, yeah, we need to transform this to lowercase. Yeah, we need to transform this to lowercase, and then spread all of its value for that. The question is that is with differing effects. But is the string aren't exactly. You must be careful which level of character are you iterating. For example, split will split the UTF 16 code units. I will separate surrogate pairs. String indexes also refers to the index of each UTF code. On the other hand, symbol.iterator iterate by Unicode code points. Iterating through graphemes cluster will require some custom code. Split into two long surrogates. Backhand index pointing right, dark skin tone. But it is using that particular syntax. Exactly. If you use a split, it's pointing to that UTF code points, code units. Okay, so here is actually transforming that properly. And when I say is this, so spread that or expand all of this here using the spread syntax. using the express syntax. Start with substring, except by using the express syntax. Another thing is to do is something like this. You can say, hey, I want you to now split this, all of this element here, which now transform them into an array, and then sort that and join them to create this sort of first list. Okay, and then it'll be able to actually do that as supposed to. You say output false. That's interesting. It's sorted first string with the T. Unless I need to sort them. Unless I need to sort both of them. Okay. Second string sorted. No, there's no need. In fact, what I need is to sort is the second string. Exactly, sort second string. Second string. This is the string that I need to sort for this. Why is this? Because the first, is this. Because the first will contain is the word, assuming this example, the first will contain is the word, and the second is the anagram. So, by now, sorting that by it is NeetCode, yeah, and I get it. Because you can take a look at this. Exactly. Because it actually is organizing both of them. Another will be something like this. If they have the same, if this is a set and they have the same, but that, no. You can just do this. So by sorting is both of element. So you can say, hey, let me actually sort the first one. Okay, let me actually sort the first one and sort the second one. If they are the same, that'll be the good. That'll be the way to do this. So sorted first is equal to the second sorted here. Sort both strings. Okay, and then compare that with this, which is now the way of how you can do this. Exactly. So now this approach, what it's doing is to, if you submit this, all right, bit is 11% of that. Okay, no problem. Oh well. or using redos as well. This is the anagram and T, that's right. But again, this is because you are very manually doing this. This is a problem of sorted and sorted, right? This is a sorted and sorted. Iterate into that, and then now split this, and then now sort this, and then now join it. So the idea here is to be more descriptive about your solution. That's what it is. The idea here is to be descriptive about your solution, which is like this. The idea here is to be descriptive about your solution. Which there is nothing wrong with that. Okay? Which there is nothing wrong with that. But is this valid anagram? And the valid anagram. Followed by the solution. Followed by the solution. Sort the strings, exactly. Compare the string, okay, compare the string and verify if they are the same. So the approach is sort both strings. So sort both strings, okay, and it is very manual the way you do that. So it's a transform both strings to lowercase as a way to make them available to compare, because now, so transform both strings to lowercase, since the compare function, the split, the sort, yeah, transform both strings to lowercase and into an array, since the compare function sort only available exactly in arrays, okay, only available in arrays, is going to compare those charts based on the Unicode 16, you know? It's going to compare those based on the Unicode. This one. Exactly. Strings are represented fundamentally as sequence of UTF-16 code units. You know? Based on the Unicode 16, based on the is UTF, or the Universal Unicode Transformation Format 16, Unicode Unicode Transformation Format of 60 bytes, as a way to 60 bits. And bits, unlike bytes, this is just 16 positions of zeros of 1. Okay? In other words, 16 positions of zeros or 1. Okay? 16 position of zeros of 1. Okay? And because it's gonna compare those charts based on the UTF-60 code units, UTF-16 code units, that's what we need to actually put all of them in lower cases. Okay? So transform both string to lowercase, okay, and into an array to the compare function. Why? Since SOR is only available in arrays, it is going to compare those charts based on the UFT code units. It is going to compare those charts based on the UFT code units, like this. Go block. No, I want you to pad this. Code units, okay? In other words, 60 position of zeros and 1. Making it much more making it much more easy to read while being declarative and then compare both string with the object.is methods. Object.is. Okay, that's good. It should copy that. Time complexity, linear time, ON is like ON here. Yeah, it's ON here, and the space complexity is linear time, because it's only, so it doesn't affect how many elements do we have. The time complexity is linear time. Exactly, because now we have to iterate through the lower cases, a way to put all of this element here, followed by the split that. So sort is actually in place. So we actually storing all of that information is here. Space complexity is ON as well, because we are now storing all of these collections. So depend of how large the strings, the anagrams, or the normal string is, well, we need to actually take space for that as a way to now iterate through that. So sort is in place, all right? But for example, split and join, they're going to take space in memory for all of these elements there. So yeah, that's pretty much the reason why we put this. Oh, ES6, declarative approach. Using a declarative approach. So solution is this. So that'll be all for this video. That'll be all for this video. Take care. Bye-bye.